Hey everybody, so just going to do a quick walkthrough of one of the notes we took today. We also have projectile notes, so make sure you watch that other video attached to get that walkthrough as well. But first half of the hour today, we did some quick notes on what the acceleration of gravity is and the difference between mass and weight. So two terms that are related to this constant of acceleration due to gravity. First, though, we talked about the difference between mass and weight. So mass is the amount of matter in an object, and you can think of it as being the amount of stuff an object is made of. Your mass is fixed for the most part. Obviously, you can gain or lose mass, but day by day, your mass is fixed. It stays fairly constant unless you do some drastic change to it, like I'm going to cut off my foot or something crazy like that. Mass is going to stay the same. The symbol for mass is M, and the unit kg for the kilogram. So those are the standard base units that we use. Now, generally, in our everyday world, we refer to our mass as being our weight. However, weight in physics is a very different term. Your weight, according to physics, is the force that is felt by a mass due to the acceleration of gravity. So we have gravity, this force that makes everything fall towards Earth. And as things fall, they accelerate. And so they accelerate at a constant rate. This rate that we call little g here is 9.8 meters per second squared. So every second, objects accelerate at a rate of 9.8 meters per second squared. Because of that, your weight can change. It depends on where you are in our galaxy and what that value for acceleration due to gravity is. Here on Earth, it's 9.8 meters per second squared. The symbol for weight is a W, and the unit is an N for newtons. Since weight is a force, it also has the unit of force, and forces we're going to cover a little bit later in the year. Our equation is W equals mg, so weight is equal to mass times the acceleration due to gravity, 9.8 meters per second squared. So gravity is a little more complex than this, but just to make it nice and simple, all objects, regardless of how massive they are, they could be super light, they could be super heavy, assuming there's no outside forces, they all accelerate at the same rate, a rate of 9.8 meters per second squared. We also call this free fall. So falling just due to gravity, no other outside forces, also called free fall. So this means that g is a constant. Constant meaning it stays the same. It's always 9.8 meters per second squared when you are here on Earth. Now, other planets have an acceleration due to gravity. They all have gravity, and so things fall and accelerate on those planets as well. And there's a relationship to how quickly do you accelerate versus how strong that force is, and that has to do with the size of the planet. So larger planetary bodies experience a stronger gravitational force and thus a greater acceleration due to gravity. So for example, someone who has a mass of 63 kilograms on Earth will have a mass of 63 kilograms on every other planet, on Mars, on Jupiter. I guess our sun's not a planet, but sun also has a value for G. However, their weight changes. On Earth, 625 newtons, about 140 pounds. Mars is smaller, so weight is only 103 newtons or 23 pounds. Jupiter is much larger, over 1,500 newtons, over 300 pounds. And then the sun, you're in the 1,000 pounds because the sun is so massive. Our formula is pretty easy to use. Find the weight of a 2.2 kilogram watermelon. So mass is in kilograms, 2.2 kilograms. G is a constant, always 9.8 meters per second squared. So when we're looking for weight, it's just mass times gravity. So whatever your mass is times 9.8. We don't square 9.8, it's just the unit that's squared. And then we record our answer with the Newton unit.